In this video we're going to look at a two-way ANOVA, and let's just set the context here for the analysis. Well, we've got jump height data of three teams, Team A, Team B, Team C, but what we also know is what positional group the players play in of each of those teams. So we have access to two factors. Factor number one, which team do you play in, and factor number two, which position do you play in. So this is what's going to make this a two-way ANOVA. We have two factors. Because when we just analyze each factor independently, well, we can see which team jumps the highest, but we know that each team has a mix of different positional groups. And equally, when we analyze the other factor independently, well, we know that each positional group has a mix of different teams. So the two-way ANOVA enables us to look at an interaction between these factors, which is really the main reason for doing the two-way ANOVA. So the first factor is, well, which team can jump the highest, split by position. So we can look at all the defenders and see, is it the defenders of Team A, the Team B, or Team C that jump the highest, and do the same for midfielders and the same for forwards. Equally, the other interaction is, well, which position can jump the highest, split by team. So now we just look at defenders, midfielders, and forwards within Team A to see who can jump the highest, and then do the same for Team B, and then the same for Team C. So let's have a look at how we compute this data in SPSS. We'll just quickly look at Excel first so we understand the data that we're about to analyze, and it'll help us interpret the outputs that we get from SPSS as well. So here's our data. Here's our two factors or independent variables. Number one is which team you play for. Number two is which positions you play in. And here, of course, is the jump height of the corresponding player. That's our dependent variable. Now I can compute all these averages and start to look at these differences in Excel. So here's the averages split when the data split by team, and here it is when it's split by position. And here's our interaction effects. So again, we look at defenders across the three teams, or midfielders or forwards across the three teams, or equally look at the positional groups within the same team. So I can compute these averages within Excel, but what we tend to use SPSS for is to see if there's a significant difference within these averages, within these means. So let's go and look at SPSS then. So here's my data. We're going to go into Analyze, General Linear Model, Univariate Analysis, because we're only looking at one dependent variable, which is the counter movement jump or jump height. Our two factors are, of course, team and position. Now, because we're looking at interactions, it's a good idea to look at some plots, and let's split the data first by team. Got to click add, and let's also split the data by position. We are looking at three groups, so we're going to have to do some post hoc analysis. So let's get these across and let's compare using Bonferroni adjustment. And it's always a good idea to ensure that there's equal variances across the groups. There's the others as well, but just for the purpose of this video, let's just do that one. Now, if you've seen the video that I've put together on mixed ANOVA, then you'll know that SPSS doesn't run these post hoc analysis or these pairwise comparisons for the interaction effect. So we've got to click on paste and go in and do that ourselves. So here you can see, look, for team, it says, look, make the comparison and make an adjustment based on Bonferroni correction. So let's go and do that for the interaction effect. So the first one I will do is team. Then I'm going to copy that, paste it there, and do the same thing on position. But also make sure I get my table using this interaction of position times team. Okay, then we can highlight that and press play. So here is our output. So We have equal variances across the groups. This value is more than 0.05, so that's great. Let's just get stuck straight into these between subject effects. We can see that there are statistically significant differences amongst the teams, positions, and that there's an interaction effect. Great, we've got the full whammy here, so let's go and investigate that. So here's our means, so just so we can make this comparison. So we have team A, B and C, and you can see they're the same means, and when we look at the pairwise comparisons, you can see actually we lose that significant difference that we noted up here in these between subject effects. You see that's right on the cusp of that alpha level of 0.05, and this is just the consequence of doing such a conservative adjustment via the Bonferroni. You could choose other post-hoc analysis, of course, but that's a different discussion. So based on this, we now have to conclude that there is no statistically significant difference between teams. Then we can look at position, and here you should note the same means here, and these pairwise comparisons will tell us that essentially it's the forwards that jump statistically higher than defenders or midfielders. Now we come on to the interactions, and this is what we asked SPSS to do for us via the code we just wrote into the syntax. But let's just go down to the graphs first. You can see here, look, when we split the data via team, you can see that in general, team B and team C jump the highest. Team A doesn't jump very high, but actually when it comes to their forwards, you can see that they have that positional group that in stark contrast to the defenders and the midfielders, well, they jump higher compared to these other two teams. So that's quite interesting and something we can analyze and look a bit more objectively at above. And then here you can see that in general, it's the forwards that jump the highest, then the midfielders, and then the defenders. But that's not really the case for Team A. So maybe that's something that's going to be interesting to look at above. So let's go here now. So here's our data, and when we look across here, we should be able to see the same means. So here we go. They're all the same data across here. These columns here should match up nicely with these ones here, and they do. And when we look at the pairwise comparisons, that's crept over that line in the sand, so there's no statistically significant difference there. But when we go across here, we can see that there is a difference within the midfields players. And looking up here, we'll note that it's the midfielders. So these two are similar. The significant difference really is that Team A's midfielders don't jump as high, which is supported in that comparison there. The other one we look at when we've done that interaction of position times team now. So now we're over here, and you can see that these should all marry up with these averages, and we're going to use this pairwise comparison to see whether any of these averages produce any statistically significant data. And you can see that within Team B and Team C, all of their positional groups are similar. It's only when you get to Team A, and what you note about Team A then is that it would appear to be the forwards that jump the highest compared to the other groups.